Okay, my dear students, we are solving some of the important numerical problems or examples which are related to what? The equations of motion, what we studied in the last class. So let me recall three important equations of motion here. One important equation of motion is given by V is equals to U plus AT, and second equation of motion is given by S is equals to what? UT plus half AT square. The next equation of motion is given by V square is equals to U square plus 2AS. These are the three important equations of what? The motion. One more important information let me convey here is, in the given example or in the given problem, if the time is given, then you can make use of what? First or second equations. The first and second equations are strictly used when the time is given in the example. Without any doubt, you can apply first or second equation provided the time should be given in the problem. If the time is not given in any numerical problem, then you have to go for third equation of what? Motion. I guess you know the meaning of what? The terms here. V stands for final velocity, U stands for initial velocity, A is acceleration, T is time, and S is called distance traveled by the body. Now look at the problem which is given in your textbook here. Let me solve this problem. Look at the problem. An object at rest means that initially the object is in the state of rest, which means its initial velocity is 0. If the object is at rest initially, then its initial velocity is 0. An object at rest starts moving with uniform acceleration, of 1 meter per second square. Means they have given the value of acceleration. That acceleration is given by 1 meter per second square. They are asking you to calculate distance traveled by the body in 4 seconds. They are asking you to calculate distance traveled by the body, that is S value, at the end of how much time? 4 second time. As I said you can make use of first and second equation of motion provided the time is given in the problem. Obviously the time is given in the problem. They are asking you to find distance traveled by the body. Then which equation you are using? To calculate distance traveled by the body when the time is given, definitely that equation should be S is equals to UT plus half AT square is a formula which is used to calculate distance traveled by the body. So let me try the same here. The formula used here is S is equals to UT plus half AT square. Then S is equals to, what is U here? Initial velocity, which is 0 into T plus half into A. What is A here? Acceleration, which is given 1 meter per second square. The value of acceleration is 1 multiplied by, what is T here? T is a time. How much is the time here? 4 seconds. T square, therefore it should be 4 square. Okay. Then S is equals to 0 into T is 0 it is. Half as it is multiplied by 4 square. What is 4 square? That is 16. So 16 divided by 2, how much it is? It should be 8 meter. What is the distance traveled by the body here? The distance traveled by the body is equals to 8 meter. So this is how you can calculate the distance traveled by the body by using the formula S is equals to ut plus half at square is the formula used to calculate distance traveled by the body. Okay, note down this problem. Let us move to the next example here. The next example which is given in your textbook. Note down. Note down the example here. Let me take next one. An object starts from rest. An object starts from rest. From a rest, attain uniform acceleration. Attain uniform acceleration. Attain uniform acceleration of 4 meter per second square. Uniform acceleration of 4 meter per second square. What is its velocity? What is its velocity? What is its velocity at the end of half a meter? At the end of half a meter. Look at the problem carefully and read the problem once again. An object starts from rest. What is the meaning of object starts from rest? Its initial velocity is 0. Object starts from rest, therefore its initial velocity is 0. Attain uniform acceleration. What is the acceleration of the body? The acceleration of the body is 4 meter per second square. The acceleration is given, that is 4 meter per second square. So they are asking you to calculate what is its velocity. Means they are asking you to calculate its final velocity. What is its velocity at the end of half a meter? What is the meaning of at the end of half a meter? They are asking you to determine what is the velocity of a body or an object after covering how much distance? Half meter distance. They are given distance traveled by the body as half meter. When the body is covering a distance of half meter, what is its velocity? That is final velocity. Look at the problem here. Look at the problem. Is a time is given in this problem? Anywhere you are finding the time here? No. When the time is not given, as I said, you have to go for third equation of motion. Third equation of motion is used when the time is not given in the example. So, using third equation, easily I can calculate the final velocity of a body. Which is the formula here? Formula used here should be V square is equals to U square plus 2AS. Substitute the values what you know. V square as it is. What is U square? Initial velocity is 0, therefore the U square value is 0 plus 2. What is A? Acceleration. How much is the acceleration? Acceleration is 4 multiplied by, what is S? Distance traveled, that is half meter, that is 1 by 2. Next step, 2 and 2 gets cancelled. Then V square equals to 4, therefore V is equals to under root of 4. What is the meaning of V is equals to under root of 4? V is equals to root 4, which is equals to 2 meter per second. What is the velocity here? The velocity of a body is 2 meter per second. So this is another example which is given in your book. It is okay. One more, what it is, the question which is given in your textbook. I guess I didn't discuss it so far. Let me see that example also. That example which is given in your textbook is, imagine that an object is moving with uniform velocity of 7 meter per second. An object is moving with a uniform velocity of 7 meter per second, does not change its velocity at least for 10 seconds. Concentrate here. Object is moving with a velocity of 7 meter per second, and the object is not at all changing its velocity for at least 10 seconds. Up to 10 seconds, the body is moving, object is moving in such a way that its velocity is not changed. Then what is its acceleration? They asked you to determine what is its acceleration. Answer is very simple. The acceleration is 0. Why the acceleration is 0? As I said you, body can have the acceleration when the velocity changes. If the velocity of a moving body does not changes, then its acceleration should be 0. They clearly mentioned body is moving with a velocity of 7 meter per second, and it is not going to change its velocity at least up to 10 seconds. Means up to 10 seconds the body is moving with the same velocity, that is 7 meter per second. If the velocity of a body remains constant, then there is no question of what? Acceleration. When does the body can have the acceleration? Acceleration is observed, or body can have the acceleration either there is increase in velocity or else there should be decrease in velocity. In general, the velocity of a moving body should change, then only the body can have the acceleration. Otherwise, the acceleration of a body is 0. Okay, with this I will conclude this class. In the next session, I will come with more information about the lesson describing motion. Okay.